So ready and go. So in this one, there's this proposed binary operation acting on these two parts, which says it's possible to put a three-sided polygon and a seven-sided polygon together to make a four-sided polygon. And that works in this case by slotting in. So it seems to be if you have a concave portion of it, the other polygon can blank off like an antibody. So that would seem to be that you could fit a polygon inside and it would cover up all the sides bar one. It'd still have one exposed face. So just making a postulation here. If this was an n-sided polygon, you could slide it inside and blank off n-1 faces. However, it would still leave one of its faces exposed. So in fact, it would only be removing n-1 minus another one, which is n-2 faces. Unless there's a fortuitous configuration, as in this case. If that exposed face out of the recess lined up with one of the faces, then that would drop down to n-1. And if you had this bridging situation where that exposed face bridged to what were two separate faces and reduced it to 1, then it looks like the maximum you could remove is n. So the proposition here would be, by slotting that in, you couldn't remove more than n faces. So looking at this, that's removed 1, that's removed 2, that's removed 4, but you're only putting 3 in. This looks like the candidate here. And you could just run with that and go on to the next question. However, you're not going to try and prove this proposition. What you would then do is just quickly check that you can get the other situations. Which one of these is incorrect? It looks like this one. Well, you can check that rather than trying to go through some proof just by saying, can I create these situations? I only want to remove one. So if I had a recess that a triangle could fit into, to make this part into a pentagon, I would just need another 3 sides. Then I've got 1, 2, 3, 4, 5 originally. That blanks off and reduces it to 4, so that works. And this one, I want to remove 2 faces. Well, that sounds like a blending in situation. If I slot that into a recess, then it would only remove 1 face unless that blended in. So I'll make that into my hexagon now. 1, 2, 3, so another 3 sides, 4, 5, 6, and that one works. Don't need to try that, just need to check that these work. This case here, I want to remove 2, but I'm putting a 4-sided polygon in. Well, that would do just the way it is. Remove 3 sides by filling the recess, but put 1 back on with that exposed one. So to make this 6-sided one, I've got 1, 2, 3, 4, 5, 6. So that works. And in this one, I want 4 to remove all 4. That must be a bridge. So you're going to put this in to a recess and make that bridge 2 sides, and that'll knock that down to 1. So I've just got to finish off an octagon. 1, 2, 3, 4, 5, 6, 7, 8, and that's it. So C is the answer.